Hello, everybody. I'm Nick, and if you have not joined me on this channel before, I typically talk about DevOps, I talk about IT career, and a number of other things. They're usually sort of general kind of topics, usually not tutorials or full classes, but part of what I do for a living is I teach. I teach a lot of different things. I teach cloud, I teach mainly cloud, do a lot of security stuff, I teach Linux courses, I teach Python courses, I teach a number of different things, but these days, one thing I do not typically teach very much of is PERL. And that is because, as will be the title of this video, it is very likely that you have been lied to about PERL. If you are somebody who is relatively recent in your career, I mean, I don't even know how recent, maybe within the last 10 years or so, you probably are under the impression that PERL is a terrible, unreadable programming language. It should not be used. It is flawed. It has all these various different kind of faults. And you probably also have never used it, which is weird given that PERL was a dominant programming language. Now, time changes things, and we've seen other languages kind of come into the place where PERL used to sort of own the market, which is automation, DevOps, working with text streams, which is a lot of what we do in Unix. And I'm putting this video together basically as a introduction to PERL. I'm not advocating that this should be the first programming language that you learn. I'm not advocating a number of different things. Well, actually, let me just jump into this. We'll kind of go over it. So we've kind of been talking about PERL, but PERL's been around for a really, really, really long time, and it has a large number of benefits. We'll talk about some of those benefits as we kind of go through it, but just to kind of front load this a little bit, PERL is very stable. And I mean that in a number of different ways. Obviously, it's stable in that it's a, first class, excellent programming language that, is not going to crash any more than any other language. Has a lot of really nice features and things like that. But it's stable in terms of the language itself. Unlike other languages like PHP, Python, and a number of others, it doesn't dramatically break the language every few versions. Now, that is a little bit of shade. I understand that most of the languages, Python, for example, now that we've gotten to Python 3 and kind of standardized on it, a lot of the pain of that kind of process is probably behind us. But one of the really cool things about PERL is if you wrote code in PERL 20 years ago and you go run it today, it will typically work. Now, there are some exceptions if you used maybe a library that's no longer maintained, but that's true with any language. And it's a really, really, really good programming language for a lot of different reasons. But before we get into some of the good things about PERL, let's talk about some of the myths or the sort of misnomers or things about PERL. PERL is dead is one that you'll oftentimes hear. PERL is absolutely still actively used and maintained. It's probably already installed on your system for most operating systems, Windows being an exception. PERL is only for text processing. That's certainly not the case. It supports a wide range of applications, automation, things like that. So very, very simple. PERL code is always hard to read. That one is just not true. One of the things we'll talk about as we kind of get through this is there's a design philosophy in PERL that's different than, let's say, Python. And that design philosophy is there's more than one way to do it. So what that means is different people will have different takes on how to go write PERL. And if you're looking at PERL that is written in a way that is intended to be difficult to read, which was actually a thing, like there were contests to sort of, just kind of as a joke, to kind of point out how difficult you could make PERL be. But if you just standardize on a way to write Perl for an organization, or if you consider the readability of your code, it's a non-issue. Only legacy systems use Perl. That's, again, not really true. It kind of goes back to the first point. Still actively developed. CPAN, which if you're familiar with other programming languages, this would be analogous to PHP's PERL, Python's pip, Rust's cargo. There's a bunch of these. This is basically your module ecosystem. This is your sort of .NET equivalent, right? Perl is not slow. It's comparable to other scripting languages. And one of the nice things that you can go do with Perl is you can compile it. So while that's not the case out of the box, it's that's a non-issue, right? We can compile this. This can be extremely fast if you need it to be. But one of the things that I'm going to sort of introduce as an idea in this course is that every language has its place, its niche. It's the thing that you want to kind of target when you're writing code in it. So for Java, this would be the enterprise, right? So you're writing an enterprise application. For something like C#, this would be you're writing programs in the Windows ecosystem. Now, of course, there's exceptions to this, and there's .NET Core and all that kind of stuff that can go run on Linux. But when you're looking at like what is the kind of use case for something, right? Typically, each language has some areas where it excels, right? So if you're looking at doing data science stuff, for example, I probably would be looking at Python as the language that's going to go with that. Right? Perl has an interesting use case that I think applies to a lot of us, right? A lot of the people who will watch this channel, which is you already have a background in something like Unix or Linux, right? You know shell programming, right? Historically, you'd probably also know C programming, right? Nowadays, this might be Go, this might be C#, this could be some other kind of language. And typically, those environments would require a decent bit of sort of setting up to kind of get working, right? Now, this is a little bit less true than it was in the past, but you need to make sure that was installed. So, like, let's say, for example, you're using Python, you need to make sure that particular version of Python was available on your systems, things like that. So it's a different kind of use case. Perl's use case is it's really good for prototyping, right? Putting together a initial sort of attempt at like, hey, I think we want to go write something that does this. Let me kind of throw something together really quickly in Perl and get it working. Because one of the great things about Perl is the speed of development is insane, especially if you're coming from like a shell scripting background. You know how fast you can put together a shell script. Well, Perl is like the halfway point between shell scripting and like an enterprise language, right? So it allows you to do some really, really powerful things, and it allows you to kind of do that very, very quickly, right? And that's also, I think, one of the things that has led to problems with Perl is that people will sort of just throw something together without really kind of thinking through how this is going to be deployed in the long run, and then it ends up being the final solution, right? And then Perl is unmaintainable. I think actually the opposite is true. I think Perl is very maintainable because it generally doesn't break version to version. If you kind of standardize on, the early kind of, Perl 4, Perl 5 kind of series, it just kind of works, right? And you're good, right? There's not going to be issues where you need to kind of worry about, do we have the right version of Perl installed? It's just going to run. So I think in many ways it's actually more maintainable. So for me, it sits between shell and your enterprise language. So C, Java, Go, C#, whatever you want to go put in there. Very powerful. It's ideal for text processing, and it's insanely easy to learn if you know shell programming, especially if you already know another language. And it's powerful to do real projects in. And as I was talking about before, it's ideal for prototyping. So I think this is a really, really nice language. So let me give you some caveats first. If you do not currently know a programming language, I would not recommend Perl to be your first programming language, especially if you're doing this to find a job. If you're not doing this to find a job, if you don't care about a job, if this is more of a hobbyist thing for you, then absolutely Perl is a great language. There's nothing inherently wrong for it. And that's because Perl is not nearly in demand as a programming language. Things sort of come in favor and go out of favor, and as it stands, Perl is not nearly as in favor as a number of other languages. And that's part of why I'm putting this together. I don't think I'm going to change that by any means, but I do think it's worth understanding that it is a good language, and it does work very well. Now, the one place I would say that there is a substantial career benefit to knowing Perl is the fact that not nearly as many people have been learning Perl on their way up as they used to, and especially as we see like the baby boomers retiring, and Gen X and elder millennials kind of going into the managerial side of the house as opposed to necessarily being technical resources. There's a gap, right? Perl was the dominant systems engineering language, and a lot of web applications, and a lot of glueware, and a lot of just general kind of stuff. It's a cool language. A lot of things manage text. Perl is really, really, really good at dealing with text. So for example, it was the first language that supported Unicode. And it's done that for a really long time. So that's a really neat thing. But there's this gap, right? So we have all this kind of legacy stuff, right? That was written in Perl that still is probably used on your system, right? And then you've got a whole bunch of people who don't know Perl, right? So if you know, let's say Go, right, which is maybe the language that they're looking for in this particular job that you're trying to get, but they also still have all this Perl stuff that's kicking around, and you also know Perl, now you've got something that's going to differentiate you from other people. Now, you'll still probably end up writing primarily Go code in that environment, but you may be migrating Perl to Go, or you may be maintaining existing software or writing kind of things here and there, which is a nice thing to be able to go do. So as we mentioned before, Perl's motto is there's more than one way to do it. So this was coined by Larry Wall, who is the creator of Perl. And this is, again, one of the really big upsides and the downsides of Perl. Is it's very, very simple. It's very easy to go ahead and just throw something together. But the way that you do it may not be the easiest thing to read if you're not familiar with Perl, right? If you are familiar with Perl, it generally is pretty readable. You need to do a decent bit of work to make it difficult to read. You can go ahead and still be very logical about things. So to go ahead and install Perl, apt-get, yum, dnf, whatever it is you're going to be doing. If you're on FreeBSD, package. If you're on Mac, you can do brew. On Windows, there's a number of distributions of Perl. There's no official, this is the Perl that you need to go use, but Strawberry Perl seems to be the most popular one that's being used in the Windows ecosystem these days. It used to be Active Perl, and I think there was a couple other ones. But Strawberry Perl works really nicely, and it's available through Chocolatey. So that's typically the package manager that I use on Windows systems. So you just do Choco install, in this case Strawberry Perl, and it'll install that for you. So if we're honest, unless you're running Windows, it's already there. And you, unlike other languages, you don't really care what version it is, right? As long as it's relatively recent, because of things like security patches and stuff like that, right? We're good. So it's fairly straightforward. Perl has phenomenal documentation. So if you go to perl.org/docs, you'll be, you can learn the entire language through there, right? So, again, this is going to be sort of an entry level kind of course. We're going to go over the kind of core language features, kind of be a whirlwind tutorial on Perl. What I would recommend is that if you do decide that you want to go ahead and learn Perl, come up with some kind of project that you want to go do and implement it with Perl, but also go through the documentation. One of the really cool things that Perl does is it installs typically as part of the standard distribution. Sometimes this might be a separate package that you install, the Perl doc command. I'm not sure if Strawberry Perl does this by default, but let's go ahead and see. Perl doc. Perl doc. Okay. So it looks like it's not installed with Strawberry Perl. If you use something like Windows Subsystem for Linux, they go, which is going to mimic a kind of more traditional. Why is that not zooming in? That is weird. That should, all right, there we go. Yeah, so okay. Apparently on Ubuntu, which I think is the basis for this WSL, it needs to be installed separately. But this will go ahead and download that and get that going. So, so yeah, it's a very, very small package, but this is basically the full Perl documentation that you can then go ahead and look at. This is really handy if, for example, you're in an air-gapped environment, right? So that's probably not going to apply to all of us, but maybe for some of us that could be really helpful things. We do Perl doc. This is going to go give us the Perl documentation on the Perl documentation format. So there's a documentation format called POD, plain old documentation, and we can go ahead and look this up for things like our plain old function documentation. We can also go ahead and look at various different kind of pieces of things. So if we do Perl doc, Perl RE, this will give us the Perl regular expression guide. And this is a full, significant document that goes over pretty much everything you would need to know to learn, all about regular expressions in Perl. And again, if you're, offline for whatever reason, you're air-gapped, this is going to be a really handy thing to be able to go do. Or if you're just somebody who's distraction prone, right? So this is something that I'm finding more and more difficult, and I'm sure a lot of you guys are right there with me, is if you're on a internet connected device, there's just tons of different distractions. So if I open up a browser to go ahead and look at documentation, one of the things I typically try to do is not go look on YouTube for things like reference and tutorials and examples, because there could be a really interesting video, right? And I don't want to get sucked into it. With this, you can just go ahead and still be in the terminal, and you'll be, good to go. So to go use Perl, basically we use the Perl-E command on the command line. So this will evaluate an expression. So we can go ahead and do something like, Perl-E, right? Single quote, hello, or print, hello. Throw a new line in there just for good measure. I'll put one at the beginning, right? So you can go ahead and do something like that, and it will do exactly what you think it would do, right? So this gives you output. So we can go and do things like, for example, do really complex, really nice substitution with something like a Perl PLE. So this is going to print, this is going to loop, and it's going to evaluate in this case, this expression, right? So it's going to go through, and I probably should have put -I in here as well. Because that'll do it within the actual file. Now you don't actually need to go ahead and do it the way that we're showing it here with the separate dashes. You can go ahead and do something like Perl dash ple right, something along those lines. And you can also go ahead and do things like echo. Right. That'll go ahead and, oops, I gotta go complete that. Right, so that'll allow you to go and do things inline. So this is basically, just a nice sed equivalent. But, if you're on Windows, right, there's no sed by default unless you're on WSL. You can go ahead and use this, the same way that you would use sed and just be ready to go. So that's giving you some benefits, just immediately. So that's kind of a nice thing to be able to go do. Go reduce the size this a little bit. Hopefully that's legible. So we can kind of have that sort of thing on one line. So yeah, again, gives you sort of a full cross-platform sed, but also it uses full Perl regular expressions. And that's generally the kind of expressions that you probably are familiar with. If you're familiar with regular expressions, that's something that almost every other programming language in the world has adopted, is they have PCRE, which is Perl compatible regular expressions, right? Because effectively the Perl regular expression implementation is the best, right? So everybody just sort of adopted it. So to go run Perl code, basically you can put this in script just like you would with anything else. So you can go do something like user bin env Perl. You can go use user local bin Perl or whatever the path the Perl is directly, or you can go ahead and just call it like Perl and then a program name, right? So all that kind of stuff. So exactly what you want to go do. So another thing we can go ahead and do is we can do Perl -d. So this is going to be the Perl debugger, right? So we're not going to go get into debugging in this course. It's sort of an advanced feature. You can go read all about it in the Perl documentation. But this functionally gives you a REPL, right? So you can go ahead and do something like what we're looking at here, where we're doing, Perl-DE1, right? So it's going to go ahead and basically let you go evaluate one expression at a time. Right. And then we can go ahead and do, print hello world, right? We can go do my $x equals 5, right? So we can then go ahead and get the results of that. That should give me 10. That's my... Yeah, weird. But anyway, I'm not going to go worry about it too much at this point. This is sort of initial foray. And then we can go ahead and get out of here with, a quit or exit. All right. Q to quit. There we go. So that's how we can get out of there. So yeah, we have the same kind of REPL that you would expect in most other kind of languages, and you're good to go. We've talked about the Perl backwards compatibility, right? This is, one of the phenomenal benefits of it. Perl, unlike Python, does not enforce indentation, right? So obviously we want to go ahead and make sure that we have nicely written Perl for readability purposes. This is one of the things that you're going to want to go standardize on when it comes to the, Perl style guides. You can go find those really easily, and then it'll have basic things like variables are typically going to be camel case, so it'll be like foo bar, which you're probably familiar with. So the nicest ways to kind of do this is there's two utilities. There's Perl tidy and Perl critic. Right, so these are both Perl modules. You can also usually find them as separate packages, and probably the nicest way to go do that is just go configure your IDE to automatically run them when you go save your code. You can put this in your CI/CD pipeline if you're working with other people, and you can go use the cpan command to go do that. So here we do cpan install perl-tidy. This is sort of the object-oriented kind of format. Basically, it's the parent class and then the individual module. So these are going to be derived directly from Perl. We're not going to get into object-oriented kind of stuff in this course. It's typically only really used in Perl as sort of creating Perl modules, right? So it's really not something that, there are people who write object-oriented Perl code. This is not who this class is geared toward, right? And then basically the idea is you can lint and validate your code by running these two commands, right? So very, very simple to go do this. You go do something like perl tidy. If you want to go keep a backup of the original, you can do -b, and then it'll give you the formatted file that adheres to kind of standard style guides, and then Perl format example.pl will give you recommendations, right? So it'll kind of give you hey, this might be an issue, right? It also gives you sort of a severity level because these are basically sort of looking for warnings or kind of issues in your code. So obviously comment your code. So the standard kind of comment character is a pound symbol, but we also have POD and cut. So these are basically how you would go define a multi-line comment, similar to how you would see something like, quote, 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 in Python. So this is just effectively a comment string. So one of the things that we typically recommend that you could do is obviously, not only comment your script, but comment any portion of your code that might be confusing, and then, throw a plain old documentation format document on each one of your functions that's describing basically how this would be called, how it would be returned. There's a number of kind of standards for these. It doesn't really matter which one you adopt, but adopt one of them, and then have your code be self-documenting so that the next person who comes along, which could be you, can read this easily. So here we have some basic kind of just Perl components, and I think this is sort of a nice example of how simple and easy Perl is to use. We just have the print command, and then we're using hello world. Now this could also be in parentheses. Yeah. Well, could do it this way. There we go. So if that makes you feel better, do it that way. For me, I typically do. So the my here is basically defining variable scope, right? So we're doing a print statement. You can see that these all end with a semicolon. So this is going to be sort of similar to C style. One of the things that I like, some people really dislike this, but I personally like it, is that you basically have variable type hinting based on the name. So if we see, a $sign here, that means that this is a scalar variable, right? So this is going to have, a value of like a string, or it's going to be an integer, something along those lines. We're then going to go ahead and have things like arrays or hashes that will have a different preceding character. So I think that's actually very easy to read. Also, sometimes it makes sense to kind of, use kind of non-standard kind of indentation, because you want to do that for clarity. So, having a semicolon to sort of determine where something ends, as opposed to like requiring this to have the exact number of spaces for indentation, is something that I personally appreciate. Also, sometimes you'll have a system that's messed up. Maybe this is a a physical system that you need to go in and get something, fixed with, right? So I know most people these days sort of recommend treating things like cattle as opposed to pets and just sort of blowing it away if there's something wrong. But sometimes you need to go look at things for root cause analysis, kind of figure out what happened. And, that may be that you're connecting over serial connection. Maybe this is an embedded device, or, there's a lot of different kind of use cases where we might not have this really nice colored syntax highlighting. And this is handy. So that's kind of a cool thing. It also makes it immediately clear, even when something is sort of kind of embedded in another form of syntax highlighting, when we're using variables, right? So $greeting is different than greeting, right? Because it's a variable, right? So even because it's in these double quotes are treated differently in Perl compared to single quotes, again, similar to shell scripting. And it worked just, again, very, very simple. So this, again, feels very, very, very straightforward. Now, you don't necessarily need to go ahead and use the my on everything. I'm using that in this course because I think it's a good practice. And typically when I use Perl, I'll use an option called strict that'll ensure that we kind of follow best practices. And one of the best practices is defining if a variable is global or not, and typically avoiding global variables, which is generally a practice that is recommended in all languages, not just Perl. There are exceptions, whatever. And then we can go ahead and do things like this, which are just really, 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 really simple. We know what standard in is. We know what standard out is. Those are very straightforward, simple concepts. And we can go ahead and do things like just read from them. So, if I do this code here, right? So if I do, I go ahead and do Perl -e, and I go ahead and paste this in here. And hit return. It's now waiting for me to type something, right? So actually, if I go back up here, and I say print name : $name, something like this. All right. We can go ahead and undo foo, and we can see that this was, basically working as a prompt, getting that from standard in, assigning it to a variable, and then printing it out. There's no needing to load OS. There's no needing to sort of set up the module for input and dealing with standard in and starting it out. It's like, no, this is something that was written for the assumption that this is how we're going to deal with things. We're dealing with standard in, we're dealing with standard out. That's just built into the language. Let's all kind of move on and go home, right? So, things like that are just there and ready to go. So if I go zoom out of here a little bit, this might be a little bit too hard to read here. Let me close this out. We can go zoom back in over here. So this is just a little table where we have the various different types of variables, and then our sort of example usage. So we've got a scalar. A scalar is kind of what people think of as a kind of a normal variable. So this is going to be a single named value, right? So this could be a whole bunch of text, or this could be an integer, right? This could be a float value. All of those are going to be sort of under the umbrella of scalar. Now we can go do things like casting of variables and defining types and all that kind of stuff if you want to, but it's not required in Perl. We have an array. So an array is an ordered list of values. It's a little bit different than other languages where it does not necessarily need to be the same type of a value. This is simply just pointers to memory locations, and the things that we're pointing to could be strings, they could be integers, they could be a mix, right? We don't need to go define that. And then a hash is going to be a hash map, basically a dictionary, right? So this is going to be, key value pairs, right? So terminologies are going to be a little bit different than other languages. Say, for example, if you're coming from, Python, right, we would refer to this as a dictionary instead of a hash, for example, but you get the basic idea. And then to go ahead and define these, we're keeping the my syntax in here to define local variables in our current scope. So my name equals some value, at colors equals parentheses, and then we have a list of the variables separated by commas. We then have things like a dictionary in the next line, where we're looking at my percentage age. And we're going to go ahead and have Alice, and then we have this sort of arrow notation, which I actually really like. I think that's very clear in terms of what you're doing, is you're setting this key to this value. In this case, it's going to be 30, right? So, all this stuff is pretty basic and pretty easy to go pick up. The next thing that we're looking at is variable scope. So generally the my keyword is going to be used to declare a local variable. That's because most people are going to be using Perl, are going to be writing procedural style programs. So you're going to be using functions. And we then have an hour variable to basically declare a global variable. So you can go use them. Syntax there is pretty straightforward. A lot of people will recommend, as do I, the convention of using use strict and use warnings. Now, I think it may actually be that strict and warnings are sort of turned on by default now, but the idea is this is something that's toggleable, right? So you can go turn these on or turn these off. Strict will basically force you to go ahead and adhere to things like best practices of, keeping good variable scope, so you don't unintentionally overlap your variables. And then warning will sort of work similar to I forget the syntax and shell as soon as I sort of brought it up to talk about it. But basically, like if you have something that would generate a warning, it treats that like an error. So this is really useful when you're developing in order to go ahead and make sure that you avoid potential issues, right? If you decide that you don't want to go run that in production once you deploy it, that's completely fine. So we're going to take a look at variables next. Scalars, right? Again, we have strings, numbers, floats, right? All of these are valid. We can go convert between them, right? And Perl is pretty intelligent about sort of understanding. So if you define age as 30, and then you go use it in decimal math, it'll cast it as 30.0, right? Effectively. So this is an example of strings and quotes, just sort of calling the idea that single quotes and double quotes are different. So this is not the case in other languages like Python, but it is sort of standard as the case. So that's something to just kind of be aware of, and you'll be sort of good to go. So in this case, my dog equals bits. We then go and do a print on that, and we'll be basically good to go with that. So this is looking at arrays and lists. So here we're looking at basically defining them with an @ symbol. We're then going to go ahead and we go sort of break this out a little bit. So we've got our array is going to be, in this case, 1, 2, 3, ABC, right? So the characters, right, are basically being treated as single element strings. So strings are effectively their own arrays as well, but we don't need to worry about that. What we can go ahead and do is we can have this be our integer numbers, and then what we can go do is we can just refer to the elements in the array in a very similar fashion to what you would do in shell, right? Which is to use our sort of bracket notation. So we can go ahead and use bracket 0 being the first element in the array, bracket 3 being the fourth element in the array, and then we can go ahead and push things onto the array by pushing them, and we can also go ahead and do a pop, which I should have probably used here as well, which will get rid of it. So we can also go ahead and do things like join, which will basically take all of the elements in an array, go ahead and sort of wrap them in a put a comma afterwards, and sort of print out all the elements in sort of a string. So combine all these, right? So multivariable assignment. This is something that this is handy to be able to go use. I don't typically find this is something that comes up all that often, but if you want to go ahead and sort of skip having sort of a placeholder variable, we can go ahead and do in parentheses x comma y equals 4 comma 5, and that'll basically replace them. So if we wanted to go ahead and swap values without a placeholder, you can say x comma y is equal to y comma x in these parentheses, and you'll be good to go, right? So that's pretty simple. If we want to go ahead and use hashes, we've got in this case my hash equals and then parentheses, and then a parentheses and a semicolon to end this statement. And you can see that this is just really nicely formatted. One of the other cool things about this is since our spacing doesn't matter nearly as much with this, we can go ahead and do things like say, I want to have all these guys line up, right? Whoops, go back. Slide was on. Right, so yeah, we can go ahead and so we want to go ahead and make all these slides line up, or these arrows line up for kind of readability purposes, if that's something that you want to go do. And now this might be more readable to you, right? So, just stuff like that, right? You don't have to go do that, but a lot of times people would do that when writing Perl. So they'll say, like, we want to have all the commas line up, right? Little things like that, which, are not necessarily required, but for some people it makes it more readable. And that's nice. So here we can go ahead and see that we've got $hash. This is kind of an interesting thing. When we're retrieving the value, we just go use a $sign hash. And then we have the, dogs as, our value. We then have, number 3. We can go ahead and have, another hash where we have something like pancakes or delicious or whatever it is, right? So we can go ahead and kind of define it however you want to go do it. So you can go ahead and do it all in one go, sort of like this. And then we can also add new elements by just giving it a new keyword and kind of going from there. So very simple. And then there's a keys keyword that you can go use for all of the keys. So sometimes you'll want to do like a loop, and you want to go loop for all of the keys in a hash, and then retrieve the value in each one. You just use keys as your keyword there. So that's something I'll probably need to go add to this. Excuse me. Another thing that's really handy about working in Perl, and you can compare this to Python, for example, where you need to go ahead and load the OS kind of module for this to work in Python. Environmental variables are just supported out of the box. They're considered first-class variables. So all we need to go ahead and do is access the hash where all of these values are referenced, right? So we have a special hash called $env, and we can go ahead and access variables or set variables directly as if they were a regular hash. So we just have this special hash called env. And this is the kind of stuff that people talk about when they say Perl is difficult to read, right? They'll look at this and say, what are we setting? How is this working, right? Where is this value being defined? Where's this value coming from? Like maybe path was never defined earlier, right? So we're going to define a local version of path that's referenced env path. But where's env path? Well, if you know Perl and you know that we have this special env variable, that's really straightforward and easy. There's nothing confusing about it. But if you do something like this, like throw a comment above it for somebody who doesn't necessarily read Perl, saying reading from an env var, even though that might be obvious to you as somebody who writes Perl, right? Problem solved, right? No issue. So that's kind of it. We're basically good to go there. And this is really handy for things like if you're working in a Dockerized world where you want to go define various different variables as part of your Docker configuration, right? So now we can go ahead and have a secure way to go ahead and externalize configurations, right? So you can do all the kind of 12-factor stuff with Perl just like you would with anything else. And if we want to go ahead and set an environmental variable, well, again, we can go ahead and add new keys to a hash just by referencing them. So $env my var equals hello world. Boom. We're good, right? So at that point, we can go, jump over to a shell and do, env or set and go see all our environmental variables, and that will be defined, right? So that's really nice. I feel like I'm saying that's really nice a lot, but that's kind of a lot of what we're looking at over here. So let me go ahead and turn emojis off. Emoji. All right. And then we'll line that all up. So these are some of the environmental variables that you might use. Probably the most common one is going to be $_. This is default, right? So for example, let's say we're doing a loop, right? Typically we're going to go define a value to contain the iteration of the loop, right? So by convention, this is oftentimes I, right? So what you can do is you can just skip that, do for each, maybe an array or, a hash, something along those lines, and print $_. And that's, you don't need to go add I. If you think I makes it more readable, then do that. So $@ symbol. This is basically the error message or kind of status from an eval statement. So we have like a try eval that you can go ahead and do. So we don't need to go load anything else to go ahead and deal with exception handling. That's just there and ready to go. $! These are error messages from system calls, right? So if we try to go open a file, for example, and we have some kind of issue, if we want to go print out what that was, boom, there we are. If we want to go look at what our current process ID is, that's $$. If we executed a system call, which is really easy to do because we can just go throw it in backticks, right? So I could go ahead and do something like $my user or my $user equals, who am I? That would work if you're on a Unix system, right? If we had some kind of, evaluation that we wanted to go do, we can go ahead and do a question mark. If we want to go look at arguments that are being passed to our subroutine, right, we can go ahead and look at underscore, right, and then brackets, right, because it's basically a array that we're going to get those passed to us in, or yeah, it's we can go ahead and look at this really easily. If we want to go evaluate the operating system name, right, we want to go look at the name of the current script. We want to go look at our environmental variables like we looked at before. If we want to go change our input, record separation, right, normally /n, but if we want to go convert this to maybe like pipes or, commas or tabs, or if we were doing a CSV file or whatever it was, right? These are all completely valid to go do. So, there's a little bit of it that might be less readable if you don't know these. By the way, the equal signs are just an org mode thing. So that's just basically setting like code, right? So that's basically just a pre-formatted text, right? So that's a kind of a thing you can turn on, turn off in org mode, which is what I'm using to kind of do this presentation. So if we want to go do an if, right, we got if else, right? So you put your kind of various different things. So if we have, hash list equals brackets, we can, evaluate that, found brackets, else not brackets. So, so we're not doing Python here, so we're not going to be finding brackets. We'll get not found. So this is, very, very simple, right? This is an equal statement, not equal, right? We can also go ahead and have some alternative syntax. Now, depending on how familiar your environment is with Perl, and if this is going to be shared with somebody else, you may or may not decide to go use this. And I think this is something that JavaScript adopted, if memory serves. I don't write a ton of JavaScript these days. So this might be something that people are very comfortable with. But this, to my understanding, originated in Perl. So this is basically evaluating if this statement was true, and then it's going to give you a value if that was true, and then basically a fallback value, right? So that can be really handy in some instances. And if you get a whole bunch of these statements, that can be very readable, right? So that's something that a lot of times people will want to go add. But if you're not familiar with the syntax, that can be confusing. So my recommendation would be, if you're going to be working with other people who are going to read your script, don't use that. Right? Skip that syntax, or educate them about it, or just like put in something like, something like that, right? Boom, you're good to go, right? So that's, that's whatever it is, right? So we can go ahead and kind of help people. We also have a syntax that we can go use, basically what we're looking at previously, to go ahead and define a case statement, right? There's also given/when, which is, basically going to be doing the same thing, but we can go say my score is equal to 85, and then my grade equals, 90, 80, 70, 60, whatever it is. And we're going to define our values here. And then the final one that we're defining is going to be followed by our fallback value of f, right? So we can also go use given/when, which is, again, basically sort of a switch kind of a statement. So you do need to go enable this. So if memory serves, this is not the most performant thing in the world. So that's why it's sort of turned off by default. But we can go use those use statements to go enable it if you want to go do that. So let me go back down there. Right, but we have when and then the value. So this is basically doing a comparison. So this would be fine too. And this is the kind of example of things that is nice about Perl is you can do things like that where it just you line things up nicely, and you'll be good to go. Or maybe you have your default statement, you want to go ahead and have that be over here, right? That would be fine too, right? Or maybe in your environment you'd like to go ahead and have the final, bracket on the same line. Whatever it is, all of those are fine, right? So. So we also have an unless statement, and I like this. This is a handy thing. So I typically don't use it with the example that we're looking at here, but this is basically my is raining equals 0, and then it's unless is raining print, right? It's a nice day. And this prints because is rating is false, right? So let me go zoom back out there. And then we also have the kind of more standard way to go do it that you would see in most languages, which is you use a exclamation point or bang to negate, right? So this is testing not true, right? And that's fine too. You can go do that. And if I was using an if statement, as you see here, I probably would favor the second variation because to me, this would probably be easier to read if I'm coming from a different language, right? But this case, this example here, where print it's a nice day unless is raining, well, that's quite nice. That's pretty simple, right? And this is basically just using a true false, right? So is this defined, right? But this could also be some kind of condition, right? So that's a handy thing to be able to go do. So for loops, we're looking at like a list, for example. We can go and do my list equals 1, 2, 3, and then we can go do for each my num. And this is an example where we could also go ahead and do for each list. Whoops, I keep forgetting it's in presentation mode. So we can then go ahead and go over here and print $_ and then this would basically allow us to go iterate through the loop without having to go define a variable. Now, as you can see here, we still can define a variable. Right? So if you're working with other people, this is probably going to be more readable than using $_. Personally, I prefer $_. That's because I've been doing Perl since 1990-ish, right? I don't remember exactly what year, probably later 90s, but yeah, we can go do a standard C, kind of loop. So for my, I equals 0, semicolon, I is less than 10, I plus plus, or I minus minus, whatever direction you're iterating, print $i. We can also go ahead and do things like this, 1.20. And that'll give us through a range. And there's a whole bunch of ranges that we could use. We could use alphabetical ranges. We can, whatever. Going to be good to go. So basic IO. So we already looked at standard in, standard out, and standard in before, but we can also go ahead and look at standard out. So basically these two little brackets in combination means that we're talking to an IO source, right? So that's quite nice. So we can do something like while, standard in, right? We can go ahead and get, and if we omit standard in, it defaults to standard in, right? So that's sort of just a little cheat. Again, probably be nicer to write standard. That would be equally valid as well. But this is going to allow you to loop through input. So if we did, cat etc password piped into my script.pl, right? This would then print out, each line with my input, right? So that's, something along those lines could be handy. And an example, if we wanted to actually go open up a file, well, it's very, very similar. So the first thing we need to go do is open our file handle, right? But we need to go ahead and create a variable that references the thing that we're trying to open. Now, there's a bunch of different options we can go specify, but generally it's just going to be we're reading in, we're writing to it, like the direction that we're doing, that kind of thing, right? So we've got the open keyword, and by convention, typically you're going to go have an or statement here, right? So we're going to try to go do something, and if we can't, right, if that doesn't work, if that gives us a false, right? So we can go ahead and basically tell it to do something else. Again, this is nice. We don't have to have like an if statement for this. We can then go ahead and, in this case, die, right? So this is going to basically exit out of the program with the error message, can't open this file, right? And you can see here that we're getting the actual message from our operating system here, which we looked at previously, right? So if we go back to our special variables, $! Error message from our system call. So we're trying to go open up our file. We'll get the actual response from the operating system. So cool. Open a file. We've got a close command, and we can go ahead and throw again, our file handle here, which we're defining our variable file handle. That's sort of the convention. You can name it whatever you want. Most times you're kind of working with one file at a time, so you don't really need to have a whole bunch of them. But you could name it whatever you want. This is just a convention. We're also seeing the warn keyword, right? So probably what we'd want to go do is we want to have this be like a try statement or something like that. And if we couldn't open up this file, throw some kind of warning, maybe try it again. Maybe we wait off. We have some kind of logic in there to kind of handle whatever we want to go do. Probably better than die. That's a little bit drastic, but you can do whatever makes sense in that area. And closing the file handle, right? That's probably not going to be terrible. It's just not going to have that lock removed, and we'll have to go wait for that to expire. So those are pretty straightforward. And then when we want to go deal with that file, well, we already know how to go deal with an input source. It's to go wrap it in carets, right? So we basically just put $ file handle in our greater than and less than sign, and we go treat it as if this was standard in or standard out. That's it. Really, really simple. Here's another example of something we can go do that's really, really nice. We're going to be using the split keyword. Here we're defining split as colon. So what we're going to go ahead and do is we're basically going to define all of these variables using the split function. And again, we can go wrap these in parentheses. That's fine too, right? So we can go ahead and have, that's the same thing, right? So whichever one you want to go prefer is completely fine. I typically wrap it in parentheses myself, but this feels very shell scripty, right? So we can then go ahead and basically have all those variables from the different fields, and then we can go ahead and print them out, right? If we wanted to go ahead and have this be something where we're writing to it instead, we wanted to go add a to a file. We can go ahead and have it be excuse me, the other direction to output to it, right? So yeah, really, really easy to go do things like file operations, because this is kind of assuming these are the kinds of things we're going to go do. This is what this language was kind of built for, right? So these are not really things I'm going to go over in this class, but just sort of as an example, these are other types that we can go ahead and use. So pipes, for example, are kind of built in. We can just go treat that like a normal file. So we just use dash instead of, the other kind of direction. We then have, sockets. We've got the IO socket, inet, because there's different types of sockets you can go use. It could be like a local socket. We have string IO. We've got tying. Tying is really, really cool. This is if you're dealing with with a hash, like a really big hash. What you can go do is you can do tie file, and you give it a file name, and then basically what it will do is it'll keep the contents of that hash buffered, some of it in memory, but most of it will be in the actual file. Really, really handy, especially nowadays with really fast IO like NVMe. So that's pretty cool. So yeah, if we want to go do the opposite, we don't want to go ahead and kind of use a file. We can go ahead and create basically like a RAM disk or a temp file. If we want to go ahead and use a database, we can go ahead and create a database file handle, right? And then again, we can treat all this kind of stuff very similarly. So it's a full-featured language. It has all these kind of components built in, right? People have been using Perl for 1 billion years. So it works, get all the kind of stuff that you'd expect. So this is a function. We're defining the create user function. So our keyword for that is sub. So we're creating a subroutine. as the functionality there. We're then going to go ahead and basically say, in this case, we're going to define my UID and name from our array of values we're passing to it. And then we're going to go ahead and also be able to go do things like my user equals this hash. We're going to return this this user, right? So that's basically what we're doing there. Actually, we don't that. We want to go ahead and return user. So no, actually that's correct. We're returning a reference to it. So anyway, so yeah, but you could also go return just regular values. Right? That's fine too. So, but we want to go return a reference to our dictionary here. We basically want to preserve that. So the next thing we'll be looking at is my user reference is going to be creating a user. We then go ahead and get that reference back, and then we can go ahead and use that, right? So it's basically creating an equivalent hash in our local context, where we're basically good to go. So that's basically doing a function. We're calling it, returning it. Just like other languages, it's a good idea to kind of make your programs be pretty functional. So wrapping your logic in different sort of functions allows them to be tested easier, allows you to go ahead and have it sort of be self-documenting based on the function name, so you get a lot of clarity for it, all that kind of stuff. So all this kind of stuff about Perl being difficult to read, just not really true. So yeah. Again, you can also go ahead and use the parentheses. I generally almost always do, just kind of for clarity. So arguments are going to be positional, and they're going to be referenced as special variables. So this is a little bit of a kind of different. So just be aware that this is going to be a positional kind of input. Now, what you can do to get around that is to go pass like a hash or JSON or something like that to your function, and we can go deal with it that way. And that's completely fine. Gives you all the flexibility of name based variables and all that kind of stuff. But here we're looking at my a equals our first position, which again is going to be 0. We can then go ahead and define b as our second one, and then we're going to go in this case multiply these. So I think I named this guy wrong. So we're going to go multiply those. We're going to get our product back by multiplying a, or actually this is, turn that into a square. That's not the best example. So we do a b, right? And then we're going to go ahead and return the product, right? So, so yeah. There we go. So yeah, so that's pretty simple. So again, if we wanted to go ahead and pass named arguments, all we really need to go do is pass it a hash, right? So give it a dictionary or hash that we're going to go use. So what we'll need to go do is we'll need to sort of convert it. So here we've got my args, which is sort of a convention, is equal to @_, right? So it's going to basically be the entire array. So we're going to go ahead and basically just convert that to a local variable called args. And then we could go ahead and say my username equals args curly brace username. You don't need to do this, by the way. We could just use args username in our script or in our function, and would be fine. But this is sort of just showing it as a simple example. So that's pretty simple to go do. And then what we could go do is you can either define your values beforehand, or you can go ahead and pass it like so, right? So username and then equal greater than to sort of make an arrow with the value. So it basically gives you the same thing that you would see in some other languages that have keyword arguments as sort of a built-in kind of standard way to go do things. Just sort of a slightly different way of kind of implementing that. So again, really handy to go use these to go break up logic. So in this case, we've got basically a coin flip program. So what we can go ahead and do is basically go through and we're defining a subroutine called flip coin. We've got return random, and we're going to go ahead and check to see if this is greater than 0.5. Actually, I need to go and put the value of this. So basically 0 if it's less than, if it's over, then we're gonna probably need to go define my range in there. Guessed right, we're gonna have my coin, we're gonna have our guess, and that's gonna be equal to what is passed to us. And then we have a notify of outcome, which is basically giving us our print statements. And we're gonna go ahead and have basically a run game, which is going to be my coin equals flip coin, and then we're going to go guess if this is heads or tails. We're going to get our guess, and we're going to have there's a lot of things like this. So we have chomp. Chomp is a function that basically removes any of the end align stuff that you would normally have. So if this is a Windows system and we have a carriage return, it'll remove the carriage return. If this is a Unix system and it's got a new line or like a bunch of white space we don't care about, it'll just clean it up. So just chomp it off and just give me the stuff I care about, which is kind of a built-in, which is nice. And then we have, in this case, we're going to go for 5 guesses, where actually this is basically going to be your main logic, right? So this is going to be, main, right? We're then going to go ahead and run, for 1 to 5, run game, and this is going to go run our game. This is going to go through calling these functions, and it's very easy to read, right? This is not confusing. This is not something that's difficult to comprehend in terms of what it's doing. So, yeah. Now, some final stuff that we're going to be looking at is regular expressions, right? So, we're going to be looking at some of the kind of advanced kind of Perl stuff that we can look at here. So, this is something I probably would go over in a class where I was teaching this in person. But the idea here is Perl regular expressions are fantastic. We're not going to go get into them very much here, but you can absolutely go ahead and take a look at the Perl regex documentation. I'm going to just pull this up over here in a separate browser, and this goes over all of the Perl regular expression kind of stuff. And I definitely recommend that you go through this. You'll learn a ton. Basically, the way that we denote that we're dealing with a regular expression is just to go throw a little tilde on our equal sign, and this is going to go ahead and turn this into an evaluation, right? The convention is to go ahead and use slashes to go ahead and separate your components, but this is not necessary. You could go ahead and do things like greater than symbols. You use percentages. You can use whatever you kind of want as a special character into the start and end, but most people use things like slash. So here we're looking at a match because this is an M. You could also go do substitutions with an S. This will feel very, 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 very familiar for most people who have looked at this kind of stuff. And I would recommend going to regex101.com. This is a great way to look at your regular expressions. So we can go look at PCRE. So this is going to be Perl compatible regular expressions. And we don't even really need to worry about sort of defining this as Perl. But you can go ahead and look at, right, things like that, or all right, so it's going to go match our white space. there's a lot of this. You don't need to kind of memorize this stuff. You'll learn it over time, but it's very full featured when it comes to Perl, and we just have a ton of stuff. So this is sort of our quick reference for that. So modules in CPAN, basically, to install external modules with CPAN, we do CPAN and then the module name. So JSON would be a pretty common one to go use. LWP simple would be lightweight parser, I think, which is going to basically allow you to go ahead and access HTML pages typically, but it could also be like XML, I think. So we can then go ahead and basically declare dependencies. So we have something that's not always installed, but there's a cpan m command, and we also have a cpan file command. So we have the cpan file that we can go use to basically work like sort of like a requirements.txt, or pick your your programming language. So here we've got things like it requires DBI, which is our database interaction library, JSON, and we're specifying particular versions. So you can see a comma separated between the actual module and the particular version. And a requires statement says this has to be installed, and recommends is like this is something that you could install, but you don't necessarily need to. Typically for me, it's like it requires it or it doesn't, but whatever. Excuse me. So what we're going to go ahead and do is we're then going to be able to go ahead and do apt-get install cpan m, and we can go ahead and do cpan install deps. And basically what it will do is it'll basically look at the Perl files in that directory, and it'll create that cpan file for you. So this is sort of like a pip freeze if you're coming to this from a Python background. We then have excuse me, the carton command. And carton basically allows you to kind of do a similar thing where we can go ahead and use this to go ahead and dump stuff to a cpan file, but we can also go ahead and use this to install, from a cpan file, right? So we can go ahead and use that as a way to both create it and then, apply them, right? A lot of people will just use like cpan install or cpan m install and then the name of the module as like a shell script and do it that way. So whatever way you prefer. Here's an example. We're using LWP simple, and we're going to go connect to 68K news. Which is like a very, very simple site, right? So this is good for examples when you're kind of working in a text environment, right? So we can just do this. All right. All right, so we don't need that last one. We can go ahead and do Control X, Control S to save that. And then we can switch over to eShell. We can do ls. We can see that we've got our 68K Perl there. We can do cpan m. So another way you can go this is to Perl -m cpan -e. Sort of the old-fashioned way. Okay, so it took a second. So we can now go ahead and do an ls. We do PERL 68k .pl, and didn't like that in line 7. So I think that should do it. Now, this is what happens when you throw stuff together as a demo. That should be fine. All right, if it doesn't work on this one, I'm gonna. All right, yeah, we'll figure it out later on. Near file and. Huh. Did I do that in the reverse order? Anyway, so I'll have to go look at that a little bit later on. But I do that backwards. I probably did that backwards. Is what it was. Yeah, I probably do content to file handle, and then yeah, so that's probably a bit. I'll need to go look at that a little bit later on. But you get the basic idea, right? So it's very easy to go kind of do. So next thing that we're looking at is an example with the REST API. So there's a slightly different way to go do it. So this is looking at, using LW agent. This is getting talking to a REST API. So this is a great little project, which is going to be the JSON placeholder kind of tool. So this basically, if we go to this. All right. Pull this up over here again. So this is basically an API that gives you back a list of fake to-dos so you can kind of play around with. And you can see that this is just in sort of a JSON dictionary. Is kind of what we're doing here. So here we're looking at user agent new. We're then going to go ahead and open up our API. We're going to be using the response, to get our response back here. We're using the JSON kind of package to go understand what the JSON is. And then we have the data dumper kind of utility, which basically allows us to go nicely sort of output various different kinds of data types in sort of nicely kind of formatted kind of structure. So basically here what we're going to go do is we're going to be using the decode JSON function from our JSON, our module. We're then going to go ahead and basically get our response from the decoded content, right, when we're talking to our API URL. We're then going to go do a for each through our to-dos, right? So we basically turn that into a sort of a array that we can go kind of work through each one of the keys. And we're going to go basically treat this as a dictionary, and we're going to go print those out once and we're going to evaluate if that task has been completed. If it has been, yes, and then otherwise we're going to do a no, right? So we're looking for if this is done, right? Else we freak out and we get out of there, right? That's the idea there. So maybe that's a little bit easier to read. We kind of do that. But this is what this is generally going to look like when we're dealing with our sort of examples here, right? So this, pretty simple to go use. This is all very readable. This is not difficult to sort of understand. And the main thing is that this is super, super quick and easy to talk to an API, right? So another sort of module that we might want to go use instead, that's a little bit more modern, is HTTP Tiny, which is used with PERL, which is why I wasn't validating the other one, because I don't use that very much anymore, but that's sort of the historical way to go and do it. So in this case, we're defining our use strict and warnings. We're going to be using HTTP Tiny, JSON, data dumper, and this is basically the exact same program, right? So we're going to go ahead and define our user ID, and we're then going to go ahead and have our, our basically new object. So this is basically calling HTTP Tiny new, and then we're going to go ahead and get our response. So this is how we call a method from an object, by the way. So once we've defined it, we're basically creating our object HTTP. We're then doing HTTP GET. We're passing it the API URL, and then we're storing the response in a variable called response in our local context. And then we're going to go ahead and check to see if this was successful, and then we're going to go decode these. So this is basically the exact same thing that we looked at in the previous module, but I think this is a little bit nicer. It's a little bit easier to read, in my opinion, and we don't need to go install the additional kind of library. You still need to go install data dumper and JSON, which are not necessarily there for you automatically, but very simple to go do. And then one of the traditional use cases for PERL is CGI scripts, which are sort of coming back into fashion, I think, a little bit with things like fast CGI and so forth. But this is very, very simple to go do. Basically, there's a CGI package, which is one of the standard kind of built-ins, I believe. And we can go do my CGI equals CGI new to go create a new CGI object. And then we're going to go print out our various different headers. And we're going to go and have our start HTML. And yeah, I mean, this could be a template. This could be whatever you want to go do, right? So this is really, really simple to work with. Hello world, right? Simple, CGI script in PERL, and then you're kind of off to the races, right? So this is an example of using a sort of a calculator. We're going to go ahead and create a PERL module called calculator. We want to go ahead and define add. We're going to go ahead and have subtract, and we're basically going to go ahead and be able to go use those. So that's basically it. We're using a 1 here to basically always return a good value. And then the next thing we're looking at is using basically unit tests, right? Because PERL is a very still a modern language, and we can go do test-driven development with it. So the way that we go do this is we're going to be using basically there's a couple different suites. There's the kind of the test suite, and then there's test more, which is going to give you some additional kind of capabilities. But we're going to be using the is statement. This is sort of your assertion, and we're going to go ahead and call our module, and we're going to go ahead and reference our function. We're going to go give it the values and then the expected result, and then basically a string that tells it what this test was. So that way, if it failed, it would be good to go. Here we get a positive, we get a negative. Looking at subtract function, and you can go put this wherever you want. One of the convention, which I typically don't like, is you put it in the T directory. I usually call it my directory test, but that's sort of the convention, so I'll kind of stick with it here. And then the way we do this is we go use the prove command. This will be, again, something you can go install with test more, that's going to make this available. We then go ahead and do prove -L for the long format, and then the directory where our tests are relative to where we are currently, and then we can basically get the files we tested, the results back, and we're basically good to go. So yeah, again, this is sort of our whirlwind kind of kind of case. So the recommendation that I would say is, if you want to go ahead and get started with Perl, try to go throw together a Hello World application, variabilize it, take some input. So I think that would be a nice thing to go do. Another package that's useful is getops. This will allow you to go ahead and do things like script pl -- name equals foo, right, whatever it is. So you can go do stuff like that. So that might be a nice way to go do it. Try to go ahead and recreate the downloading the website example, but maybe add some command lines to this to go extend that. Maybe write a little battleship kind of tool. You can kind of just take this and kind of run with it. These are just some really simple examples, but hopefully in the time that we've been going, let me go see if I can see how long that's been. 1:30. You have seen that Perl is a very viable and usable language. So I'm going to go wrap it up now. I'd love to get feedback on this. Let me know if you found this to be useful. Anything that you think I should add to this. If you're somebody who is coming from a Perl background, if you are interested in Perl, I'd love to know why. And to, especially people who are a little bit newer in your career, who haven't been as exposed to it. And yeah, I'm not sure if I'm going to go leave this up for a long time. I may sort of refine this and then turn this into a class that I'll offer somewhere for a reasonable price. But I wanted to just sort of put it out there initially and kind of get some feedback on it. So thanks for watching. Have a great one. See ya.